Welcome everybody to our first R&D tech talk about the main differences between our two laser-based powder bed fusion processes for metals and polymers. And we do this together with our Director of Research and Development, Hannes. Welcome to the show. And I think we directly jump into the main differences. So Hannes, what are the main differences between the two processes?
Well, first of all, thank you, Daniel, for inviting me to the TechTalk. It's a pleasure to be here. The main difference between the polymer and the metals process is that the polymer process is a hot process where we heat the complete powder bed to a temperature very close to the melting temperature. The metals process, on the other hand, is a cold process, so that means the heating is relatively low compared to the melting temperature, and most of the heat input is with the laser.
Okay, and why can we not do this also in the metal process to heat up just below the melting temperature?
Let me start the other way around. So the reason we do this on the polymer side is because of thermally induced stress. So if we wouldn't do this, the parts would deform, curl up immediately. In metals, the issue exists as well, but it's much less severe. So, and at the same time, heating a machine up to 1000 degrees would be very, very challenging and also very expensive. And so that's why we don't do this. Yeah, we do some heating, but not to the extent like in polymers.
Okay, and that's probably also because we need support structures for the metal process.
That's right. So to avoid deformation because of the residual stress, we have these supports, but they also serve other functions. One is to avoid shifting of the part because of its weight. Metal parts are quite heavy, and we also need to remove heat to avoid overheating of the part.
And what about the laser? Do we use the same type of laser, or is there any difference?
Actually, there is a difference. There are two main differences. One is the wavelength, and for metals we use standard fiber lasers. They are very easy to use, and we can use them for metals. For polymers we can't use them because of the absorption spectrum, especially of white polymers, and therefore we use a CO2 laser. The other difference is in power. You need much more power to melt metals than for melting polymers.
I think that's it for the main differences. So let's talk about the future of additive manufacturing. So what can we expect from our R&D in order to speed up productivity and decrease cost per part?
Yeah, so before I answer your question, I would like to mention that another really important aspect for R&D is new materials. So we are working on several approaches to create new materials for AM and also make materials processable that currently are very hard or even impossible to process. And then on the long run, I'm convinced we need to develop AM-specific materials, not just use standard polymers or casting alloys for it. Coming back to your productivity question, this is indeed one of the main challenges for industrial adoption. And what you can do here is, of course, to lower costs for the machine, for the material, and then also to increase productivity. For that you can use more than one laser, like we do, for instance, in our M400-4, but you can't really scale this up too much. At some point it just becomes impractical, and therefore we are working on different approaches to input energy. Can't really tell you any details right now, but there's some exciting stuff happening.
Okay, and what about simulation and monitoring?
Yeah, that's also one of our focus areas in R&D, to improve the predictability of the process for our customers and also create the right tools to check if these predictions are actually correct. So for the second you need monitoring. On the metal side we already have 3 monitoring products, and for the polymer side we will also include it.
Let's talk about the buzzwords. Automation and digitization, so what we can expect about that in the future.
Well, digitalization comes sort of natural because the technology is digital. what the next step is to include more options to get data out of the machine, collect and analyze that data. So that is what EOS Connect is for. And regarding automation, I think the next gen AM project we're doing together with Premium Aerotech and Daimler is a very nice showcase how this can look in the future.
Okay, I think there's a lot of stuff that's coming up. So guys, first of all, thank you, Hannes.
Thank you.
Thank you for watching, and next time we will talk about lasers and optics in more detail. So see you next time, guys. Goodbye.